Okay, I haven't actually done this question before, but I have an idea, so you can help me do it, okay? So, but it's kind of I think one of the tricky things about this question is kind of it's being right, yeah? Like a lot of people I think can get answers. You have to get the right
Oh
answer.
yes, this is one of those questions.
Yeah, so I guess the question asks for how many dots are there, not just the vertical column.
Can I explain it?
So it's the vertical column plus. I guess you could
Oh my god.
let's
Vertical column, I'm so stupid.
that's how you got it, yeah. So
I'm so
let
stupid.
n be the number of dots. Why is it like this? In the vertical column. Yeah?
That's what I did. That's totally what I do.
Yeah. Okay, so I guess the nice thing is like how do you get a triangle? Well, you can either get a triangle using dots from the vertical column or not using dots from the vertical column, right? And if you use dots from the vertical column, you can use at most two, right? Okay. So you can't use so basically the you can pick any 3 points that aren't on a line and you get a triangle. Yeah. Okay. So um if you want to pick say one thing from the vertical column, just one dot from the vertical column, that means you have to pick these two dots, right? So if you just have one triangles with one dot, so one dot in vertical column in column. You need to use the side dots, yeah. But if you use the side dots, you can't use all the vertical dots, right? You can only use you can't use the bottom one, yeah. Okay. Okay, and then so there's n minus what everything is erased. Okay, there's n minus one of these, yeah? Right? Okay. And even though I'm doing it with n, I really recommend the beginners to just actually like count the triangles and keep adding them, right? But it's actually kind of tricky because there's so many triangles to get. But I think that's what you should do if you're just starting out. And then you find a pattern and you get it what it's equal to, yeah. Okay, but I'm kind of trying to show you how like this kind of thing gets easier when you build your system up, okay? Alright, so then you can have, can you have no dots in the vertical column?
No.
You can't, right? Because there's only two other dots, yeah? Then but you can have two dots in the vertical column, yeah? You can't have three, right? Yeah. Okay. So the good thing about the two dots is you can have any two, yeah? Right? And any two, and then once you pick two, you can either go with the left one or the right one, yeah? So that's literally n choose two times two, yeah? Is that what you all got?
Yeah.
Did anyone do it like this?
I just did. So I got the n minus one part because of one dot in the column, and then for the two dots in the column, I just did 1 plus 2 plus 3 plus 4 dot 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 all the way to plus n minus 1.
Yeah, I guess that's what n choose two is. So you have n choose two is n times n minus one over two. That's n choose two.
Yeah.
And you times that by two, yeah? And now what we want to do is we want to plus n minus one, yeah, equals, what's it equal to? 2024?
Can't you simplify that to like, so first of all, so it's n times n minus 1 divided by 2 times 2, right?
Yeah.
So it becomes n times n minus 1 plus n minus 1.
Yeah.
So then it becomes n plus 1 times n minus 1.
Yeah. Is that what you did? 2024. Yeah?
So that means that n has to be 40. So that means that it's equal to n squared minus 1 squared. So that means n squared equals 2025, which means n equals 45. So that means the amount of dots is just 45 plus 2, which is 47.
Yeah. I mean, or you could factor. So, like, the thing is, I think you could also factorize this, right?
Yes.
I guess one good thing is the other question already had a factorization. So you actually had to factorize it. Like it was like, what is it? 8 times 11 times 23, right? So if we can find two factors that times 2024 and differ by 2, right? Can we do that?
44 times 46.
So 44 times 46, yeah?
Because it's the difference of squares.
Yeah.
Difference of slight.
Yeah. Okay, so 44 is 4 times 11, and then 23 is 2 times 46, yeah? So that means n minus 1 is equal to 44, right? What? Sorry. Let's do well, obviously n minus 1 is 44, n plus 1 is 46, right?
Yeah.
And then the answer is n plus 2, so it's 47. Yeah, but you should include your working. See, the off by 2 ones are the worst. Off by 1. You would have got 2 points, yeah. Alright, are there any questions about this? Did you guys do it that way?
No, I just found the pattern.
That's looking right. So then n plus 2, that's the answer is n plus 2, right? It's looking for n plus 2. It's 47. Yeah. It's actually kind of a tricky question, I guess, because if you were just counting the triangles, that's doable, right? But like I think even the bright kids, they kind of miss some triangles. Like it's like you have one there, right? And then they get that triangle fine, but then like they sometimes they get that one maybe, but then they like say they miss this triangle, you know what I mean? Or they miss like this triangle. But if you just count the number of dots, then it's easier. You can't miss any triangles.
Is this me or did anyone else